2. Ecology.
So, many of you have sent me emails or visited me during office hours to complain about the material on systems theory. Some of your complaints are partly correct. The theory is vague and it can be applied to almost anything. Rather than being frustrated by this fact, though, I want you to understand that this universality is the beauty of systems theory. Don't you see? Scientists need a tool that can be easily applied and adapted to describe any group of variables that interact in a predictable and recurring pattern. This tool is systems theory. Let's go over it again, because it will be on the exam. Who can tell me just what a system is? Anyone?
Isn't a system like the actual things in a relationship and like what the things do together?
Okay, that's a pretty accurate description. But let me just tighten up your definition a little. A system is defined as a process that is a result of its parts and their interactions. We call these parts elements. So every system has elements. Each element in the system has certain characteristics that are relevant to the functioning of the system. We call these attributes. So every element has attributes. Now, these elements and attributes have a cause and effect relationship with respect to one another. So, every system features relationships. Now, we have the three things that make up the system. We have the elements, the attributes, and the relationships. Now, what example did we discuss last time?
It was the food chain, right?
Right. Okay. Let's go through the example and apply these terms. The food chain system is the system of energy moving around in the ecosystem. So, the food chain has elements. We can distinguish four major ones: the sun, plants, herbivores, and carnivores. Those are the four elements of our system. These elements have attributes, right? In this case, the attribute is energy. We start off with the sun, which has, say, 100,000 units of energy. The sun radiates this energy onto the earth, where the plants are. Plants can then absorb this energy via photosynthesis. Who remembers what photosynthesis is?
That's the process that plants use to make food, I think. They breathe in carbon dioxide and breathe out oxygen, right? The opposite of us.
Good, that's right. Oxygen is indeed a waste product of photosynthesis. That, in fact, is another attribute in a larger system. But I don't want us to think about oxygen or carbon dioxide now. Let's stick to energy as our attribute. Okay. So, we now have a relationship between the sun and plants on Earth. In photosynthesis, a plant takes light, energy, water, and carbon dioxide and converts them into simple sugars and oxygen. These simple sugars are the plant's food and thus its source of energy. Plants can capture about 1% of the radiated energy from the sun. That 1% of energy is the plant's attribute. So, 1% of the sun's 100,000 units of energy leaves us with 1,000 units of energy being absorbed by the plants. The next element in our system is the herbivores. This term means plant eaters in Latin, so these are plant-eating animals. The herbivores eat the plants. Here we have another relationship, and from this, the herbivores are able to absorb 10% of the plant's energy. Remember, we started with 100,000 units of energy from the sun. The plants absorbed 1% or 1,000 units of this energy. So, now we have the herbivores eating the plants and taking 10% of these 1,000 units of energy, which leaves 100 units of energy left at the herbivore level. The final level is the carnivores, which is Latin for meat eaters. These animals, in turn, can consume 10% of the energy from the herbivores. Remember, the herbivores ended up with 100 units of energy. Therefore, we are finally left with 10 units of energy at the level of the carnivores. They make up the level furthest from the sun. So, this is our system. The attribute we followed is the energy starting from nuclear reactions in the sun and passing through the four elements in the system, from the sun to the plants, and finally ending with the consumption of herbivores by carnivores.
Number 1. How does the food chain work? Summarize the process by putting the steps in order. Number 2. What are the 2 reasons that students complained about systems theory? Choose 2 answers. Number 3. What is an example the professor gives of a system that systems theory can be applied to? Number 4. Why does the professor say this?
This term means plant eaters in Latin, so these are plant-eating animals.